Alright, what's up guys? In this video, I'm going to pick up some differential equations here, and we're going to solve an initial value problem. This will be example number 1, and I'll be posting a lot of initial value problems for us to work on. Alright, so we're asked to solve this initial value problem. Y prime is equal to 0.05y plus 10, and we're given y of 0 is equal to 10. So basically, that's the initial condition. So we need to separate the variables and integrate both sides. So the first thing that we need to do is divide both sides by 0 times 0, 5y plus 10. So that'll be 1 over 0.05y plus 10 dy is equal to the integral of 1 dt. And we'll integrate this side as well. Alright, so if we integrate this side over here, this will give us 20 ln. We can drop the absolute value bars, it'll be 0.05 y plus 10 plus c1. And if we integrate 1 with respect to t, that'll give us t plus c2. The two constants here will just get absorbed into one big one. And so we'll write this as 20 ln 0.05 y plus 10 is equal to t plus c. Now, the initial condition, basically all that is doing for us is helping us solve for the constant. So that was y of 0 is equal to 10. So let's substitute in 0 for t and 10 for y. So we'll get 20 ln 0.05 multiplied by 10, and then plus 10, and then it'll be equal to 0 plus c. So this will be 20 ln, looks like we'll get 10.5, and that's going to be equal to c. Or if you don't like that, you could just write it as c is equal to 20 ln of 10.5. Okay. So now when we go back to what we had, we'll have 20 ln of 0.05 y plus 10 is equal to t plus 20 ln of 0 or 10.5. So again, all the initial condition allows us to do is just solve for the constant, and we just need to solve for y basically. So we'll begin by dividing both sides by 20. So if we do that, we'll get ln 0.05 y plus 10 is going to be equal to t over 20 plus ln of 10.5. Now we'll need to solve for y, so what we're going to have to do is exponentiate both sides. So this would be e to the ln of 0.05y plus 10, and then we got to exponentiate this side, which is t over 20 plus ln of 10.5. I'm going to go to another sheet so that we can finish it up. We're pretty much almost done. We're just kind of like fine tuning right now. We're almost done though. Alright, so what that does is that just gives us 0.05 y plus 10. And if we exponentiate that side, well, I'll just write that as 10.5 e to the t over 20. Now we need to solve for y, so we'll multiply both sides by 100 and then subtract what we get from both sides. So let's multiply both sides by 100. We could divide both sides by 0.05 0.05, but we would still have to subtract 10 from the other side, so it doesn't really make a difference. So if we multiply both sides by 100, we'll simply get 5y plus 1,000, and that's going to be 1,050 e to the t over 20. We can subtract 1,000 from both sides, so that'll be 5y is equal to 1050 e to the t over 20 minus 1,000. Divide both sides by 5, we get y is equal to, I think that's going to be 210. I'm going to check. E to the t over 20 minus, I think it's going to be 200, but let me check. All right, let me check. Just make sure. Yep, 210, and then I'm pretty sure I was right on that, but I'm just checking anyway. Yeah, that's all right. So this would be the general solution. So your final answer to this initial value problem is y of t is equal to 210 e to the t over 20 minus 200. That's the answer. So that was initial value problem number 1. Again, I'll post another one either tomorrow or the day after that. All right, so that's going to be it. We'll see y'all next time.